Alright, appears I've pressed the button. So here we go again. Another video trying to explain what I think is pretty obvious. But anyway, it's the way it is. It's the world that exists. Blah, 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 blah. So we'll just do a couple of these little preliminary things and everything should. I'll just explain one more time. Because that's what you have to do. Is explain, and then explain, and then explain, and then explain, and explain, and explain. Anyway. So the Ian Gosling guy has posted another, just a completely redundant video where he's, just wallowing in his surprise regarding the 4 times the height is only twice the energy thing. So he just can't accept that because they're going to keep arguing that energy is about distance and it has nothing to do with time. Now all these distance arguments go away once you get out of once you get to a non-friction environment. So in space, if you move something twice the velocity, it only goes twice the distance. That's all you're going to get out of it. It's not going to be anything else, okay? Because the slow thing won't be retarded in any way by its slow speed, and it will effectively make up the difference in terms of how far it'll go in a certain amount of time. That's its velocity. All right, so the real argument is when you're pushing against gravity, the idea is the extra velocity, you have an advantage. It's just a fact. All right, so get rid of this, and we'll just draw this over and over and over again. Because apparently we have to. And we shouldn't have to, but we do have to. So, in their comments, which I'll read, they think they've somehow solved the problem, and because they've somehow calculated their way out of it. So the simple argument is this is one of the reasons you can know. All right, so I've repeatedly drawn this scenario. Okay, you have a mass, a gravitational body of some kind, and you're going to do a flyby. You're just going to zoom past it. And the idea is well, what's gravity going to do? And what does gravity really care about, or how is it going to affect you? And they think that for every foot you take this distance, that somehow that's gravity is going to affect you. So it doesn't matter how fast you go. So if you spend 1 second zooming across, you will get pushed towards the gravitational mass the same amount that if you took 3 days to make the voyage. And I'm obviously making the argument that whatever you think gravity is, bent geodesic, or you think it's, like I do, a pressure or a moving force. The fact is that it's about how long you're exposed to the force. So the time, it's just all about time. All right, that's all that matters, is how much time are you being affected? How long is it pushing on you? Will decide how much it affects you. And so they keep arguing as if some other truth is possible, but they won't explain what the other truth would be. So, this is something I'd like them to explain. If they think gravity is about, every foot. I mean, it doesn't even say that, right? It says 9.8 meters per second. It doesn't say 9.8 meters of pressure per foot or per meter. It says per second. It's about how long you're in it. So this is all goes back to Galileo, and so you have this 1 to 3 relationship. Okay, so the first unit of time, you do this distance. The second unit of time, you do this much larger distance because of the increase in your velocity. And you only get the same 9.8 meters of effect in these two circumstances. So this is 9.8 meters. This whole distance is only 9.8 meters of influence. And then it gets even a bigger distance, the fifth, 1, 3, 5, 7, are the ratios. So the same is true when you're going up against the force. You just reverse the circumstance in terms of understanding. It's not reversed, frankly. You're going fast here, and then you go slow up here again. So it's the same difference. You only get the 9.8 meters of resistance in the first unit of time, and then 9.8 meters of resistance in this little tiny section when you're starting to slow down and stop. And so it's the same relationship. And so all you need is twice the velocity, okay, and you'll go 4 times the distance. And the same thing happens if you're going across the surface, because gravity is what's going to be causing your friction, and the facts are just the same facts. Whether you're going against gravity this way, paint sprayer spraying paint on you, the faster you're going, the less paint gets on you. If it's raining, the faster you go, the less total amount of rain you'll be exposed to, the quicker you go through it. Not very complicated, frankly, shouldn't be an argument. So the whole idea is about Hooke's law and spring compression. So you can compress a spring with a unit of mass. You hang a mass on here. So you have one mass, and the spring expands this much. So it starts off there, and alright, and then you go 2 masses, okay, twice the mass, and it'll go twice the compression, okay, twice this expansion. So you get 2 units of expansion. These are supposed to be equal units, but whatever, close enough. And so it only takes a 2 mass. So if I weigh a 2 mass in my hand, I put a 1 mass in my hand, it weighs 1 mass. If I put another mass, double the mass, 2 mass in my hand, it'll only weigh 2. It won't weigh 4. It won't feel like it weighs 4 pounds. So if I put 1 pound in my hand, it weighs 1 pound. I put 2 pounds in, it weighs like 2 pounds. It's twice as much, not 4 times as much. So they're arguing now that it weighs 4 times as much. That somehow it's, I can't do that. So the simple argument is that twice this compression will give you twice the velocity, which will give you 4 times the distance. It's just a fact. Up against the gravity, twice the velocity will give you 4 times the distance in the gravity. And if you could expound on that, multiply that over and over again, you'll keep gaining this huge amount of efficiency. So the faster you can go, the less time you'll be in the gravity, the less force you have to overcome in total per mile, and the better and better and better your fuel economy gets in terms of how many miles you can go on a gallon of fuel. So those are the real facts. So the paradox is that I can do 2 units of lifting to put 2 1 masses on a spring, okay, and then I can take that compression, which would be twice the compression, twice the mass, twice the compression, and then I can take twice the compression, that 2x the compression, and I can launch one object 4 times the distance. So I can get 4 units of distance out of only 2 units of work. Okay. But again, it's not the same, because the only reason why this is an advantage is because you're going faster, therefore you're in the gravity less time. So it's technically not the same amount of work. This 4 times the distance is not 4 times the work. It's only twice the work, because it's only 2 units of time. You could always make it the units of time anything. And in those 2 units, you're only collecting, for part of the time, you're not collecting as much. 1/3 is less force is affecting you through this part of the voyage as in this part of the voyage. Alright, so nothing's changed in 4 days or whatever, and they think they've got some solution. There's no solution. They're just saying things that are just flatly wrong, that somehow twice the weight feels like 4 times the work or energy, when no, it doesn't. It feels like twice. All right. So it just has to do with circular mathematics fundamentally, and nothing else. Nothing else useful. All right. So we were supposed to get something brilliant from the Falwell guy. He was supposed to have some solution according to Brozo, but we don't have any evidence of any solution or anything. So he says, hi there, Ian. According to Hooke's law, 2x the compression takes twice the amount of force. Right. It's twice the mass. Not much else to say. And whether you extend or compress the spring. So it's not according to Hooke's law. It's just according to the fact that, as a practical matter, that's all there is. And springs collect energy, so they collect weight. All right. It does indeed take 2x the force in newtons, as I have tested it, or 2x the weight in mass. Okay. As you displace the spring 2x the displacement, so more mush about displacements when that's completely variable depending on the spring you use. You use a really stiff spring, you only compress it a little bit. You use a loose spring, you compress it a lot, but who cares? Or 2 times the distance, then let go. You have now doubled the distance the force is applied over. So how fast the spring expands depends on how much mass you put on the spring. So if you don't put any mass at all, the spring will gain a very high velocity because it's almost zero mass except for the mass of the spring, and it will way overshoot and oscillate, okay, because the energy won't get out of the spring. But if you put a mass on, then the mass will collect the energy. It will accelerate to the maximum speed that it can accelerate to based on its mass and the total force in the spring, and you'll get some kind of velocity. So if you use, for example, a 1 kilogram and it goes 10 miles an hour, if you put a 5 kilogram on, it'll go 20 miles an hour. All right. E equals Fxd. So we don't need the x. But anyway, force times distance. No, it's force times time. You want to know how much energy it takes, you just figure out how much time is it going to take at that velocity to get from point A to point B. So you set a velocity, you set a distance, and it's over. You know how much time. Time will tell you what force you overcame. All right, so it's just a wrong formula. It doesn't get right answers. It's just a byproduct of forcing the mathematics to fix a bad equation, which was 1/2 mv squared. So this distance crap is plainly crap. Galileo proved it to be crap. It's been crap for a long time. And why you went backwards from Galileo, Descartes, and Newton's insight remains a big question. And you went backwards without being provided any really conclusive evidence. Little gimmick experiments. And you've decided to throw out all that they gained by doing extensive experiments. So the force has been doubled, and so has the distance. And again, the only thing that changes about the distance is the Galilean reality, that the faster you're going, the less time you're in the force. It's a time-dependent force. It happens per second or per unit of time. So it's per a unit of time that you're affected. So if you can get from A to B in 2 seconds instead of 4 seconds, you'll only be opposing half the amount of force. Oh shit! Anyway, it's like this is like teaching kindergarten or something. So as an example, say the force for the first compression is 1 Newton and the distance of the compression is 10 centimeters. So again, it really isn't about the distance you compress the spring and all this crap. It's just the reality is that springs are proportional. So twice the energy, twice the effect on the spring. twice the crap you're going to get back. And so he does 1 times 10 equals 10. In the second compression, it takes 2 newtons of compression of 20 centimeters. Yes, so what? It's twice the weight. And so because of their wacky formula, 2 times 20 equals 40. Because they're measuring the distance, they're not measuring the actual force you're actually having to overcome. So remember, if I launch something at twice the speed, you can understand in the first unit of time, I've gone 3 units of distance. In the second unit of time, I'm only going to go 1 unit of distance. I'm only going to be opposing 1 unit of force. And in the first 3 units of distance, I only opposed 1 unit of force. 9.8 meters worth of force. All right. So Ian says, oh dear, I see a problem because of my free energy video. I hope you don't think I was still thinking along those lines. Well, what lines were you thinking about? You were recognizing that there's an apparent paradox, okay, in the sense that it only takes 2 units of distance to create 4 units of distance. And that can't be right by your theory that all distance is equal. Okay. In this one, yes, going to get around to a video to explain the paradox. I don't think he will accomplish that task. For me, it takes a graph. Oh, yeah, so they just have to, create some distractions, get off the subject, distort the subject enough to pretend they resolve something, which they can't resolve, frankly. You can't resolve it. It's a fact of gravity. Okay. And work to help. The fact is that the 2 mass, or the double the force, how to explain that? Is different. 2 9-pound hits, hitting with 9 pounds of force twice, is different than hitting with 18 pounds worth of force. I can't make 18 pounds with 2 independent 9-pound hits. I have to separate them, make them parallel. I have to make them happen in the same unit of time. So the only way I can combine them is to be able to create a circumstance where they happen in the same time. If they don't happen in the same time, it's just 9 pounds, 9 pounds, 9 pounds. It can't push deeper because it can't create any extra pressure. So to go from 9 pounds to 10 pounds requires 10 pounds of pressure. You can't do it with a 9-pound hit. All right. Thanks for the comment. I'm not ready to convert to Gary's philosophy quite yet. So, the argument is it's not converting to my philosophy. It's converting to Galileo, Descartes, and Newton, and recognizing that gravity is a time-dependent force. So that's all. Explain this first bit of the drawing. Did I put this back up? No, I didn't. Yeah, so yeah, this is what you have to explain. Do you understand that gravity affects you based on how much time you're in the gravity free falling, and that's how you collect energy from gravity, and you're not going to collect it any other way. All right. So that's the philosophy. You have some other philosophy. I'd like to be able to understand it, so it'd be nice if you would explore it and explain to me how gravity is about per unit of distance, and it doesn't matter how fast I go by a gravitational body. I can go really, really slow, or I can go really, really fast, and it's the same exact amount of force that's going to affect me because it's just about distance. Just explain how that can possibly be the truth, and you might get somewhere in this conversation. But until you do that, I have absolutely no good reason to accept your theory that it's about distance, when it's obvious to me it's about time. Okay. P.S. I've added this to the description in case anybody thinks badly of me. It's just hilarious. Yeah, whatever that even means. I mean, you've contrived this nonsense as an argument. You don't want to get to the facts. You just want to slander people and malign them. Well, okay, that's what you're doing. So you're just making clear that's your only agenda here. Anyway. So then Faultless says, thanks for the reply. It does indeed take 4 times the energy to compress it twice as much. So even though it's just a plain fact that if I want to compress the spring twice, all I do is find somebody that weighs twice as much. So I compress it this much with a 50-pound person, and I compress it this much with a 100-pound person. So if I want to change it, I just double the weight. And to double the weight, all I have to do is double the velocity. So if I want to, double the weight, I have to double the velocity. And we know, oh, that's right, in gravity, I have to go 4 times the distance to double the velocity. All right, because I need the extra time. All right, I need more time in the free fall. Okay, I'm sure you can feel the difference in the amount of effort you are putting in. So he's saying it takes 4 times the mass, the weight, and yet you only put twice the weight on the scale. Somehow the twice the weight on the scale somehow weighs 4 times. Even though it's clearly only twice the weight, somehow it weighs 4 times. I mean, it's completely idiotic. Yes, no free lunch. You get back what you put in. But that's not really the subject. The subject is understanding what you're actually doing. Are you overcoming a force or are you not? Or what are you force or you're fighting? P.S. I've been thinking about the paradox when the first weight is lifted up 2 distance and takes, so nothing ever gets lifted 2 distances, and takes an amount of effort work against gravity. But when the weight is attached to the spring, the force of the gravity then acts on it and extends the spring by 1 unit of distance in the opposite direction. Yes, the weight is one thing. You pulling for the second unit of, say, distance is adding the 10 to 18 thing. The first 9 can be created by the weight. You could add more stretch to the spring, but you're only going to get what you added. You're only going to get the 9 pounds. You're not going to get the 18 pounds. Not sure if this makes it more paradoxical. LOL. Alright, and then Stephen Bro chimes in with almost a nothing comment. And look, it has a little heart. And 2 thumbs up. I mean, for vacuous mush. Anyway, it is interesting, Ian. Thumbs up. If you were paying to transport goods 10 miles, you'd expect to pay 4 times more to transport 40 miles. So that's the whole point of the conversation. Who really believes that? Who really believes it takes 4 times more fuel to go twice as fast? Do you really believe that? Do you really believe that the rocket that's going up into space, that there's no advantage to going faster and faster? Again, why wouldn't they just take their time? Why do the expensive stuff of forcing a whole bunch of energy to come out of the rocket when you could do like the jet plane thing and you could just go 300 or 400 or 500 miles an hour, not have to worry about the thing falling apart and seals and all kinds of other crap? Well, the reason is because you won't get into space. That's the reason. The reason is you'll run out of fuel. Because it is about time. It is about getting your velocity as high as possible to get out of the influence of the gravity. Alright, even if the recipient lived in the sky. So he really does think it just doesn't matter how fast you lift something off, that the real advantage is you're escaping the gravity by limiting the amount of time you're exposed to it. So that simple idea, that you escape a gravitational pressure, a force against you, by decreasing the amount of time you're exposed to the force. So he really thinks the paint sprayer gets the same amount of paint on you no matter what speed you go through the spray. It's the same amount of paint that'll hit the object. He really thinks that's true. And this got a heart plus thumbs ups. And that's the argument he's making. So you people really do believe that? I mean, I didn't really think you were, all aboard with that. Like you'd say, okay, I'm going to defend some of this, but I'm not going to defend all of it. But you're really going to go all in, and you're going to tell me that you really believe that there's no advantage to increasing your velocity when you're trying to evade a gravitational obstacle. Then you're really stupid. Yeah, there's not much else to say. Wow. Much dumber than I thought. All right. So I don't think there's much point in playing this. It's just he's just going over what he already showed as if it's miraculous, and there's nothing in it's miraculous. It's pretty much been the subject for over a year now. It's not a big deal. Yes, 4 times the height, twice the velocity. That's the rule.
Stretch, if you like. I wanted to show it again. So that's 1 unit of displacement.
Very exciting.
Very high at all. That's 1 unit.
Yes.
Just over that first line, sort of thing.
Yeah, so he's doing exactly the same thing he did redundantly over and over again in the other video. It's just 4 times.
That's 1 unit. 2 units now.
Right. So again, this has been the conversation for over a year. This is the accepted truth. You are giving it twice the velocity. It takes 4. This is in the Mythbusters video. I mean, this fact has been part of the conversation. It's not at all interesting in the sense that it doesn't add any new value to see it this way. I don't think it makes any difference. We've seen it, in lots of ways already, over and over and over again. So that's all he does, apparently. Complete waste of time.
1 unit of displacement gives you 1 height, but doubling the compression of the spring doesn't give you 2 lots of energy, it gives you 4 lots of energy.
Right, so he says it gives you 4 lots of energy, and the whole point is that in the first unit of time you traveled 3 of the 4 units of distance, and then the last one is the slow one. It's 1 unit of time, but it's only 1 unit of distance. And that's the Galilean observation about the reality. And clearly that's perfectly consistent with the idea that it's a time-dependent force. And the fact is that you overcame the same amount of pressure against you in the first 3 units of distance that you had to overcome in the last 1 unit of distance. And that unit of 1 unit plus 2 units of time is the entire function of understanding the force. It's mgt, not mgh. It's work equals force times the amount of time you're having to overcome the force. It's so obvious. Let's see what he says.
That's his formula, 1/2 k.
So he just keeps, he has a formula. He says, this means something to me. I'm going to keep writing it down and forcing people to believe it. So this is the silly potential energy that they also write as mgh, because the height would be the distance. And it's not the truth. It's not real energy. It's potential kinetic energy. It's not potential real energy. Certainly isn't potential momentum. So, there's no logic in this statement. I'm just saying there's no logic to defend the statement. It's not about distance. It's about time.
X squared, where x is the displacement. Interesting, that.
So obviously it isn't interesting. in the sense that it's pretty dissectable. It's pretty understandable that 2 units of time is 2 units of force. It's not 4 units of force.
I just wanted to make this again because some people don't.
See, you just want to make it again, so be completely redundant, saying something nobody disputes with a premise that's retarded. Okay, the premise is, here's my equation that you dispute, and I'll just keep gurgitating it as if, because I can write it over and over again, you should believe it. That's not an argument in its defense. And clearly, what you're demonstrating isn't in its defense, because again, I can just lift one mass, 1 unit of distance, then lift another mass, 1 unit of distance, lift against only 2 units of distance, and I will create the same spring compression that will create the 4 units of distance for 1 mass. So you haven't solved the paradox at all. You haven't touched the real subject at all. You're just evading it again. How do I get back to the beginning? Let's just see if there's any last words.
Interesting, that.
All right, so not very... yeah, so not interesting is what the proper thing to say is. Anyway, so the whole video only has 4 thumbs up, and yet the comments have 2. Yeah. Well, anyway, it just seems like troll kind of behavior. Anyway, so somebody just thumbs up every comment. You know, very classy. Anyway, yeah, so that's enough of that. So I guess we'll see if anybody's around, and if not, maybe I'll call that a video. I guess I could play something else. I was looking at these. That's the ticker tape cart thing. Let's see if I have another one of those. Well, first I'll check see if there's any, no, nothing. Okay. Oh, I still don't have the Firefox. Well, you don't need to see the comments. You really didn't even need to see the stupid spring, frankly. Alright, so let's see. I think I have something better than this. I think. Can't be sure. Something I thought was interesting anyway. Franklin Hu made a video. So this is angular momentum, so it's probably, I really don't want to get into that subject, but since I did it, I guess. So this is, it's 10 years old. More, 13 years ago. So I don't recall this video. I thought I had looked through his channel, but I don't recall it. So anyway, oh, God bless. Yeah, thank you, God bless. It's just a little scary. Let's see. Can you tell me the mechanism did you use exactly to pull the batteries towards the center? It is kind of irritating. I don't know what, everybody has different perception, I guess, how to make a video, but Franklin, I don't get him because, he doesn't explain anything. It doesn't really show what the fuck he's doing, even back then. Alright, so this is just the simple skater analogy of pulling the masses in, and you get 4 times the rotational speed, not twice the rotational speed. And
I have an experiment here. Quadruple the speed. So let's try that. Okay, we got her spun up there. And I'm going to pull it into that mark. And there you go. It should be going about 4 times as fast. And I can let it back.
Okay, so what you would notice is that he has to use real force to pull them in. And that force is what's adding the increase in the velocity. So the increase in the velocity is being accounted for by the increase in the amount of force he has to apply to pull them in. So that's, you're not getting it for free. So I don't know if I can make an analogy to gravity, but obviously if you use gravity, if there was a strong gravity and you go into the gravity, it would be increasing your velocity if the downward pressure is pushing you into a smaller orbit, because you'll keep the velocity you had, and you're going to add a component in the direction you're going to be able to move to a different orbit. You don't push into the orbit straight, you push into the orbit on a parabola. And so that's what's creating the extra momentum. So it is extra work to pull against what somebody might call the centrifugal force. You have to push in against that, and in doing that, that's the energy that's causing the acceleration to be 4 times instead of 2 times. So it is interesting in the context of levers, but levers aren't about, the lever experiments we're doing aren't about changing the positions of masses during any part of the test. So it really is a different kind of test. But anyways, interesting video.
That again. Turn back to its old initial speed. And I can pull it in again.
Right. So that's the added energy. Trying to figure out how he did that too. It's a little difficult to tell. It has some mechanism that pulls the batteries in, slides them on the hanger. Okay. But it's hard to tell what exactly that is. Alright, but you can sort of understand that there would definitely be a force you have to overcome to be able to pull the batteries into the tighter circle, and it's that added force that you're applying that has to go somewhere, and the only place for it to go is into the speed of the batteries. Alright, so let's see, there was another video. Paste. So I've been using Bing instead of Google, and so I'm getting different results, which is, it's a little bit helpful. So I'm seeing videos I hadn't seen before, searching on YouTube. Oh, this is just the old basketball thing. Let's see, what part of this was interesting? It's a Bruce Yearney video 5 years ago. And it's the...
Are you looking for manufacturing solutions? Or simply, you just need to find a better supplier? So here's your...
So
That's awesome. So let's go.
It's just doing the basketball, so he's going to drop different things. He's going to put different things on top of the basketball. And the game is you're really just stealing the energy of the basketball. And then there's a part where he says, the prediction is 9 times. The small ball should go 9 times, and he's only getting the results of 6 times, which is sort of interesting. But obviously it just has to do with the mass and the velocities. Now, what you don't ever see them calculate in these experiments, so the one I'll have to find is to see if they do because what you're really doing, this is again kind of creating a mechanism where you're doing conversions between heavy objects and light objects. So you're basically taking the energy of the basketball. So that's just both of them drop side by side.
Now, instead of dropping them side by side, what about if I put the tennis ball on top of the basketball and release it? Well, let's see what happens.
Alright, so that's the classic experiment. The basketball bounces less high because basically it's going to give its energy to the tennis ball. Now, if they did the calculation for kinetic energy, they are, in a sense, making free energy in this experiment because the kinetic energy of the tennis ball will be higher, than what the basketball started with. So the momentum numbers will be okay, and the kinetic energy numbers will go in the wrong direction. So if you could steal the energy from the tennis ball, which is a little more complicated, and give it to the basketball, he would lose a lot of energy by the kinetic energy theory. And the inverse creates free energy. So what they never calculate is the velocity of the tennis ball and after. And the fact is because that velocity is going to be high, 6 times higher, something like that, it's going to mean that the total energy of the system will be more the total energy was when he dropped it. Well, when it hit the ground. So clearly the basketball loses distance. So it only bounces there where it should have bounced twice as high. So it loses about half of its velocity. What would have been its velocity. And the tennis ball gains multiples of that because of its much smaller mass.
1, 2, 3. That's pretty good. Good catch.
Oh, look, my
2, 3.
look, my dinner.
So just dropping it from higher and higher heights, which, you know, gets a little more complicated in terms of the two objects staying together. So it does mess it up a little bit. Alright, so then he tries it upside down, so that ought to be worth seeing. Okay. So he's got the tennis ball below the basketball. Now the basketball will gain a little bit of energy from the tennis ball, be very little effect, and it's going
Let's
to be
see what
baseball.
happens. Let's go. 1, 2, 3.
Alright, so that didn't hit the ground perfect enough. The ball wasn't centered, so you have the problem now where you have a really tiny center of mass for the basketball because of its size, and you can't really hit its center of mass, and so it goes sideways. So they keep failing to get the center of the basketball over the tennis ball, where it's really easy to get the center of the tennis ball over the basketball center. Close enough. There.
Now, how about if we just drop the tennis?
So they did okay that time. And you can see the basketball goes a little bit higher, but not much, and it's still almost all the energy from the tennis ball. The tennis ball didn't go very high at all.
Ball on top of the basketball and see what happens. Well, that's disappointing.
Yeah, well, he didn't quantify it at all, so it looks like, I guess it bounces a little higher. Tennis balls lose a lot more than you think. I mean, 25%. They're not all that elastic. It's a pretty inefficient absorber of energy.
So what is going on here? Well,
A storer of energy.
let's track the height of the basketball when it bounces by itself versus when the ball's on top of it. Okay, so we'll drop it at your head height. It's coming up to about there. Let's try that again. Right there. All right, good. It's coming up to about there. Now let's try this with the ball on top. The difference in the bounces is said to be the momentum transferring from the basketball into the tennis ball. And ideally, this is said to be able to go about 9 times higher than what this does.
Yeah, it depends on how good your tennis ball is, I guess. You probably have a pretty flat tennis ball. But anyway, it doesn't really matter.
When we set about testing it, our results weren't nearly that good. The best we could come up with is about 6 times higher than the height of the basketball.
But the point is the velocity is really high, so by the kinetic energy theory, the tennis ball has a lot of energy. More energy than the basketball started with. And that's a real problem, frankly, in terms of getting right answers. Because that's not a right answer. Yeah. So, anyway. Alright, so that was something else anyway. It's not exactly the best view I gave you of it, but whatever. Close enough. It'll have to do. Hell with it. Alright, so we'll see if there's any chatters around, and if not, we'll just move along. The hey stuff I don't really do. Not really a hello kind of person, but whatever. I don't think that experiment was accurate. I don't know what experiment you're talking about, so that's not very helpful. I mean, the dropping the ball on top of the basketball thing that's a classic experiment. So, done many ways. It's just transferring energy from a big heavy thing to a small thing. And obviously, when the energy's in the small thing, it looks like more energy. It's like the bullet. The bullet looks like more energy, clearly, than the gun. But it isn't. Same momentum. Same total momentum. And such. I wonder what the old D Hillsters will be up to this weekend. I don't think there was a notice video of who they're going to talk to. Just don't remember. But they are tedious, irritating. So probably no point in looking, Gary. So just irritate you. I have to go through all this crap to find it. Hell with that. And I'm doing it anyway. Hell with it, but I'll do it anyway. Let's see. New study finds mysterious rise of chemicals that, let's see, destroy ozone layer. Whatever. Yeah. I didn't respond to. I mean, I can't even watch her other video, but I want to get around to it where she's defending going faster than the speed of light, making matter go faster than the speed of light. I mean, it's such a stupid thing to defend. And apparently she also really does believe there are intelligent aliens in the universe. I don't know. Other life forms. Blah, blah, blah. Not a good reason. Alright, I don't see anything, so whatever. Maybe the Chappellers won't be Chappelling this week. Who knows? Alright, let's see. Nothing new, really. Okay, did Brozo make a new video? No, he's, it's his typical thing, Oh yeah, I've got it. I got the proof. I got the evidence. And he was going to make this huge debunk of the Mythbusters video. Never did it. He said he was going to make a new video experiment to demonstrate. He said he already had done the experiment. It already proved it. Already done. So yeah, where is it? Waiting on those new videos like the one from Brozo or Ian Gosling. I'm just saying why, they even hyped up this Falwell character as if he was going to add or make a contribution that was somehow significant. And all he did was recite an old tired formula and say, see, the formula says. It doesn't demonstrate, doesn't do anything to fix the paradox. 2 units of mass create 2 units of weight, double the weight. And that doubled weight can produce the force necessary to launch the one object 4 times higher. That's just a fact. The formula doesn't explain that. So, yes, I wish they would get to the fundamentals and just say what they believe in. I mean, just Ian Gosling, do you believe in conservation of momentum, the law, that in a closed experiment, you have to conserve the momentum, that it's like a substance and you have to show where the substance goes. So if stuff stops moving, you have to explain what is moving, the stuff you're looking at, because the energy has to go somewhere. So do you believe in that or don't you? Because the only way you're creating your logical escapes to defend kinetic energy is to pretty much say you don't believe in conservation of momentum. And so you have to explain, I think, you have to defend that statement. If you don't believe there's conservation of momentum, your argument isn't with me. Your argument is with physics. So your tone should be directing your argument to the conventional theory and pointing out how the conventional theory that there's some law of conservation of momentum is wrong. What, you didn't see the Mythbusters experiment? I have a copy. I should put it up on my website because apparently they took it down for copyright reasons or whatever. It's so stupid in so many ways, right? So they're basically, look, they have two cars. They're basically just crashing cars into brick walls just to see what happens, right? So they try to crash a truck or crash a car, and they're just doing this crash analysis, right? Because that's what the show was about, is just making things blow up or make big sounds. And so one of the guys said, well, 250-mile-an-hour crashes is like a 100-mile-an-hour crash. So they wanted to test that as being the truth. Now the problem is they weren't really talking about it correctly. From the person in the car going 50 miles an hour, it doesn't matter whether they hit a brick wall or they hit another car going 50 miles an hour. From that person's perspective, the car, it's still a brick wall. It's always just a brick wall. But if somebody was in between the two car crashes, obviously it would feel like 100 miles an hour. All right. So they couldn't even get that right. But what they did do was this simple test of taking a car and crashing at 50 miles an hour, then taking a car and crashing it at 100 miles an hour. So the 50-mile-an-hour car crashed so much, and then the 100-mile-an-hour crash twice as much. So they did it. They duplicated that using a mechanism, a pendulum with clay, and they simulated the 50-mile-an-hour crash versus the 100-mile-an-hour crash, and they came out with the same result. That is, twice the speed, twice the compression in the clay. And then they barely observed while they were doing that, hey, by the kinetic energy formula, this is supposed to be 4 times as much. So it just occurred to them to think about kinetic energy, and they didn't even apply it to the regular car crashes. It wasn't until they did the clay experiment that they observed it. And their explanation was to crush a can in their hands and say, see, the can doesn't crush evenly. Somehow that explains why there's this huge difference in their results, which was just really silly. So considering how much goes into the show and how many advisors and all kinds of other crappy people they have working for them, it was really a very poor show. All right. Gary, what do you think of Briggs' case against... fuck this. We're not doing fucking Trump crap, so I guess we'll just block you. I mean, fuck you. You can't even come close to realizing that's not what I'm doing here. Talking physics, you fuckhead. Jesus. God damn it, people. Trump should be convicted for tax evasion for the last 40 years. I mean, it's just... there's so many things he could be convicted of. This fact that they're pulling these little crappy he bought off his mistress with, and the fact is they all do it, right? They all spend the campaign funds on all kinds of bullshit. So, I mean, the whole thing is just such a pile of crap. But yes, he should be in jail for the 400 other crimes he has committed. Anyway, for the Mythbuster experiment, if they were crashing in a scale instead of a wall, they probably could have measured it better. They could have just done, a spring. They could have used springs, and they would see how much the spring compresses. And the fact is, the spring will compress only twice as much. 4 times the distance, twice the spring compression. So just the opposite of Ian Gosling's experiment, right? He's doing this, look, twice the compression, 4 times the distance. Well, you could do it the opposite way. 4 times the distance, only twice the compression. You know. Duh. Yeah. Yeah. I don't think hitting a wall means much. Well, you can think it doesn't mean much. It's pretty much a pretty good way to cancel something's energy. So if it's a really solid wall, it's going to reject energy transfer, and so all the energy is going to get reflected, and the car is going to have to absorb its differential, 0 and 50, and it's going to have to absorb that differential. So I don't think there's anything wrong with that theory of crushing something, as long as it's made out of something that's non-explosive, or there's some other reason that it won't absorb the energy in a consistent way. Now, I guess there's obvious, like the tin can, it has resistance in the beginning because of the way the can is engineered. But once you start bending it, once it starts to bend, it bends really easy and crushes really easy, and then it stops crushing easy at the end when you've taken all the air out. So, obviously cars or anything else you smash against a brick wall can have those, it's like an egg, the shell has some resistance, but once you break the shell, the rest of the goop is pretty easy to move. But whatever. I don't think there's anything intrinsically wrong with using smashing experiments, but it would be better to collect the energy, and then you can see it. So find something to collect it in, like a spring, and then you can actually see the energy you collected. I haven't seen the Mythbusters either. I thought they just crashed through the wall. No, they're crashing against an immovable object. A very solid brick wall with maybe steel in front of it or something. It's a really solid, non-movable wall. But it's in my past videos. I have plenty of videos that have Mythbuster in the title. So, blah, 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 blah. Yeah, I don't think you'll gain much from, like I said, it's really a simple video. I'm not saying it didn't hurt to watch it. I'm just saying it's really just doing something very simple. So, it's a 7 minutes of clip of video. I can't believe they did a half-hour show out of it, because you're just saying it's so simple. How could they make a half-hour show out of something so simple? Twice the speed, twice the rec, not 4 times the rec. Even Brozo has a video where he's claiming to partially debunk it, so some of it's in that, but he doesn't play the Mythbusters video. In a couple of my videos, I'm playing the actual video, so you can see the video in my videos. I mean, there's some question about whether they got the height right to get twice the velocity and all this other crap. So there were some issues. But the basic visual effect of the clay compressing twice as much at twice the speed, and the cars crushing twice as much at twice the speed, is sort of hard to miss. I haven't seen any, so I did look for, with the show titles, and I tried to see if there was any show titles that were close, and not really. It's all piss up a rope stuff. I mean, they're all just doing antic videos, unfortunately. It'd be nice if they did have like a physics buster show, where they just took all these different physics ideas and put them to a test, and tried to test them, relativity and speed of light and all these different kind of things. Those would be more interesting, but actually testing these proclamations regarding the positron or the neutrino or quarks, or to try to find some way to test for them besides the classic way. But no, we don't have that show. Let's see. They seem to have the most funding to make good experiments. Well, whatever. It's old news, right? The show is not on anymore, right? So I'm assuming they made lots of money from the show. Well, I would assume they did okay, yeah. Blah, 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 blah. I frankly didn't much like the, I didn't like the personality of either character. I liked the Junkyard Wars. That was a good show until they turned that into a theater, It was sort of, that was a real interesting show in terms of trying to make something out of junk and, pushing hardware limitations and all that kind of crap. But I guess they just run out of, kind of tasks, and so they all become the same kind of task, either launching something or making a torpedo, or, they just keep trying to make ballistic objects of some kind. So, it's not close enough to the, it's like even the robot war thing, it just runs out once they figure out how to maximize, the function of the robot. It's just, it's just what crushes the other robots first wins. It's not really accomplishing a task. But it's funny how all that stuff does die out. I don't think they still have any of that kind of stuff anymore. Who knows? I don't know what the fuck's on TV, so I have no idea. I think it's all, find the most retarded humans on the planet right now and videotape their lifestyle. I think those are all the TV shows there are now. Find somebody who's actually married to their sister or something. Just find something just totally, that's gross. It is hard to understand what people find entertaining. It doesn't work for me. I seen a new video about gravitons. Well, that's I'm very excited for you. Yeah. As I understand the graviton, it's it's a politon. So somehow it hits something and causes it to move in the opposite direction to the thing that hit it. It's like the opposite. It's like unmomentum. It's like a reverse momentumaton. Which just frankly makes, just so insanely silly that, it's nothing you can say except, boy, that's insanely silly. A politon. Yeah, that's what, I guess they should call them politons. I'm surprised there are not really a whole lot of shows on physics. well, whatever there is, are just the documentary kind of stuff, and they're, the Al-Kahari hypey bullshit. I think it would open up more people who would be interested in the subject. And I think it does more damage than good. So, I mean, it's like whatever that girl is who does some physics videos. Strange name she has for her channel. Anyway, I mean, she got interested because she saw the Dr. Quantum video as a kid. And, it's full of just lies. And you're just saying, why would that inspire somebody? So bad. Tested the pause anyway. It was while I was here. Sort of a pause. Pause for me. Where the hell fuck were we? Oh yeah, okay. Yeah, so shows on physics that aren't... I mean, physics is kind of boring, some of it, But I think all of the stuff I have revealed isn't very boring, so I'm interested just because, I think it's really interesting that all of their hypey woo physics is completely vulnerable to being replaced by something much, much, much simpler. And, science really hasn't done science. They've just done science fiction, Real stories aren't as, obviously people have less incentive to deal with the realities because there's always advantages to the exaggerations and the hyperbole and all of that crap, the clickbait. It works. But people really don't live in reality. They really don't do it. They live in their little sanitized fairy worlds, of their daydreams. Well, sorry about the allergies. Mine's about average. Average allergies. We just had 3 really hot days. Well, 2 really hot days, I guess, 90 degrees, and it's a little rough on trying to start new plants. It's a little kind of rough weather for little seedlings. And no rain, so that was part of the problem. I didn't have any stored rain water, so I had to use real water, which is annoying. But anyway, whatever. It's just part of life. Yeah, we only have brush fires in New Jersey, really. It's not a huge threat, but. An actual real forest fire, because it's such a densely populated state that I guess there isn't any huge forest to actually burn without a bunch of people getting in the way that don't burn very well. But it has been exceptionally windy this last 3 months. I mean, just crazy wind. I mean, stuff I've had, that was stable for years here, for a couple of years, just didn't survive this year's winds. I think the interesting aspects, here. How will it all end? Heat, death, or big freeze? Just depends on whether you think the universe is opened or closed. I mean, if the universe is, open or closed in the sense of open to nothing, but if the universe just goes on and on and on, obviously it won't be a heat death. So you have to think that there's a place outside the universe that's cold for it to be a heat death. If there isn't a place outside the universe that's cold, then there won't be a heat death, because obviously there's always going to be stuff leaking back in. So everything you lose, you get back again. So you can't die a heat death that way. But whatever, we've already been over this so many times that I don't think it's a very interesting subject, frankly. But yeah, I don't know. Big Bang, I don't think so. I think oscillating universe makes more sense, but there's so little real hard data to base anything on. I'm just saying the whole Big Bang thing is just based on redshift substantially. I don't even know how they contrived cosmic background radiation to be evidence of a Big Bang, just because it makes no sense. The stuff moving the speed of light would not be getting to us late. Can't do that. Anyway, I like to see physical examples because it's easier to understand rather than seeing a bunch of equations and try to understand this stuff. Fine. Let's see. I think the interesting aspects of physics is in the experiments rather than the math. Obviously seeing is believing and all that crap, but as I pointed out, the history of the kinetic energy formula was dependent on one stupid clay experiment. If it wasn't for that one stupid clay experiment, where people really didn't think about the difference between dropping round objects and flat objects and different shaped objects, the difference between a pointed arrow and a non-pointed arrow, in experiments like a gun is not very revealing, because it does seem, especially if you do close-ups on what the bullet is doing, that the bullet is doing more than what the gun's recoil is doing. All right? But it's deceptive, because you really don't get the idea that the gun's 1,000 times heavier. And so there should be 1,000 times difference, when you watch what the little atoms over here are doing versus the atoms over here. Well, yeah, there's 1,000 times more, punching power in the atoms over here than is over there. They're carrying more per atom. So I say experiments are great, and what you need is a variety of them. So you need to not only show how fast something spins, you also have to show it taking 4 times more fuel to go twice as fast. You have to do more than one experiment and show that it works from different places. And that's what doesn't exist in physics anymore. Drawing an explanation seems to simplify the math. Well, some math becomes, intuitive. I mean, the squaring idea, it makes so much sense when you think of the Pythagorean thing and you actually draw the triangle and then draw the squares that are making the triangle. And then you get the idea of the area created by the length of the sides. And it becomes so much more understandable why there would be a relationship between those areas. And even the parabolic orbits, when you actually do cut them into timed sections, and you see that it's the same volume per time, okay, of the, how fast the thing's moving. And, it just makes it so much easier to understand that, yes, you're going faster and you're covering more space in less time, and so you're cutting a bigger pie section. So sometimes graphically understanding the geometry that's being described by some of the mathematics, but so much of the mathematics isn't about rational geometry anymore. It's four-dimensional geometry. It's not rational geometry. All right, drawing how the math would work helps. I'm just saying you're not going to draw how Schrodinger's equation works. So there's no point in saying the math without qualifying what math you're talking about. And again, I don't think anyone's ever going to be able to draw the squared velocity geometry. Good luck with that. It's like squaring a mass. I mean, these aren't squarables. Now, let's see, how long have I been here? An hour and 17. I could go a little longer, I guess. Has Mindless Marble said anything recently? All he said is that somehow I've horribly perverted Brozo's experiment. When it's so visual, so we're back to, you see it. So Brozo did the lever experiment, where he shot the one mass twice the distance, and he shot the two mass twice as massive from half the distance. And the results were, just so obvious that the two mass went half as fast. It covered distance at half the rate. I mean, it was just obviously the truth, and it was nowhere near 0.4 faster. The lighter one didn't go 0.4 faster, which kinetic energy predicts. But the prediction in itself, in my opinion, is invalid in the sense that what Mindless Marbles is saying overtly is he doesn't believe in conservation of momentum. So why doesn't he make that argument? Why doesn't he explicitly say, I don't believe in conservation of momentum? And, why play with this, that this is about arguing with me when he's arguing with conventional physics? He's arguing with the law of conservation of momentum. He has to explain where it all went. Where did the 0.6 go? So if the lighter object only travels 1.4, where did the 0.6 go? Can you show that the fulcrum got hotter? Can you show there's more weight on it? Can you show something that would indicate where the energy went? Okay, well, see you next time and such, or whenever. Goodbye. Yeah, that's what I'll say. Whatever. I don't think you have to announce your entrance or announce your exit, but whatever. I suppose it's polite and such. The work won't do itself. Yes, okay. I'm sorry you have to go to work. Or you have to do work. Or whatever. I am likewise blighted by chores. Some of them I don't mind, though. I'm one of those people that could cut grass all day, or some kind of jobs that are really simple. I just yeah, I could do this all day. Use KE to get some free work done. Yeah, well, that's true. You got to just figure out how to do your job in such a way as you're, in the job clock, 4 times as long, but you're only twice the time. Yeah, that's kind of funny. You need a job pushing against gravity, right? And so you just measure how much work you're doing at your job by how far you go in the gravity. And you'll be a big winner. Work faster for the first half hour, and you can do 7 hours work in a half hour. But it'll only feel like, 1.5 times more work. But it's kind of funny that physics isn't really about physical things anymore. It's so unphysical. Everything they're creating is to turn everything into something non-real, into a non-thing, a non-physical thing. They're all just abstractions, It's really not physics. It is really strange that people can't grasp the idea that we're constantly fighting against gravity. Well, I keep trying to say it, but obviously you feel the ground pushing you back all the time. Like it's constantly doing it. And if it's constantly pushing you back, but you're not going anywhere, then something must be pushing you down first, and then you're pop back up, and then just push you. You must be you get the idea that there's got to be something else that's happening. I'm bouncing in gravity. I'm not really, because the ground wouldn't have to keep pushing me back. If I'd stay where it pushed me, away. If I stayed away, then it wouldn't keep pushing me, right? It only pushes me because I keep having to push into it. It has to, I have to push into it for it to push me out. Push in, push out. It's got to be the way it works. And we just happen to be oscillating in the gravity at a high enough frequency that we don't sense the oscillation. But it seems obviously that we're doing it. And maybe it's just disguised by the fact that for the parts that gravity's pushing back up, there's other parts that are going down at the same time the gravity's pushing up, so we don't see the difference because my ass doesn't actually do that part. My ass only does the up part where the rest of me keeps pushing it down. So, it's not a true oscillation, but it's a true oscillation in the sense that there's a constant force coming in and a constant force pushing up. But obviously the little atoms and the little pieces that are getting pushed all the time are little different ones. Little different bits are getting pushed. Yeah, it's just, unfortunately it's so obvious to me that that's the way it works. I just can't do their bent geodesic crapola and I mean, the worst part, I guess, is yeah, the idea that it's not a real force. I mean, I guess can't experience gravity as something other than a real force. And one, as I can understand, it's just moving the electrons and the protons. It doesn't care about me. Okay? It just cares about the matter bits, the little pieces that make my matter, the little material objects that I'm made out of. I mean, I'm made out of material objects. I'm not a material object. I'm made out of material objects. And, you know, the stuff I'm made out of is doing the moving. The bits are moving. I'm just doing what the little universe did first. And such. So I guess maybe we'll leave it there. Well, I got 4 minutes, make it an hour and 30, so maybe I can fill 4 minutes. You think you'll stream in the evening again? Whatever. I think there's a likelihood that there will be opportunity for that, yes. There just isn't enough going on lately to justify anything more than these videos. Because no one's advancing the argument. Because no one's arguing the argument. The argument is conservation of momentum and whether gravity is a per unit of time force, which it seems like it must be because that's exactly how they describe it. 9.8 meters per second, not per meter. And such. Let's see what else. Yeah, not much else. Does the concept of work being force times distance make sense? Why are you asking me? Oh, I guess you didn't see earlier. I mean, I already talked about it. Force times distance makes sense. I drew it in the beginning of this video. It makes no sense. All that matters is how long you're being affected by a gravitational influence. So wherever I put the influence, it's about how long I'm in it. Same is true for like magnetism. The faster you go through magnetism, the less the magnetism can bend you. Or is that force times time? Well, again, I've only made videos basically asserting that, yes, about a month ago I started stating overtly that it's not MGH, it's MGT. That none of these formulas are right. The work equation is not force times distance, it's force times time. None that I haven't seen any Piro comments. He's just a hit and runner. He never really stays in a thread because he frankly can't, because he doesn't have any context. He's never on the subject. He's never watched the reference material. He has, he's just talking out of his ass, without paying any attention to the real conversation. So, I guess you would say, thankfully, no, because all Hero can do is make noises. You can't, you can't fart a tune. It's just noise. He does have strange interests. I really couldn't spend my time on the internet, watching videos by people with all kinds of issues. It's like the Snake Plisskenus thing. His channel's gone, so who knows whether he deleted it or YouTube deleted it. Who knows what the story is? But it's just all this drama, and it's like, I really couldn't do that all day. Or part of the day. Seems a waste of neurology, and it's kind of a boner killer. It just isn't. I don't see any fun in it. It's not entertaining, frankly, to watch human tragedy. So you talk about lifting a 2 mass 1 unit of distance and a 1 mass 4 units of distance. But in regards to the lifting force, the distance doesn't really matter. Well, of course it matters in the sense that it's an amount of time. So the distance is still a time, a unit of time. Unit of time. 1 unit of distance does take a unit of time. So you can't separate that. The catch is that if you go at a high enough velocity, you get a whole bunch of units of distance for 1 unit of time. It doesn't really matter. It's the time it takes to lift the masses. Yes, how fast you lift a mass will decide how much work you have to do. So if I lift 10 pounds really, really, really slowly, I'll burn thousands upon thousands of calories. But if I lift the 10 pounds really fast, I'm not going to burn shit. So yes, the force is compounded by time. And so if you liberate yourself from exposure to the force by evading it, by shortening the time you're exposed to the force, obviously that's very beneficial. And the paradox is that you can put 2 units of time in. You get 2 units of time out, but it's 4 times the distance. And frankly, the paradox is not really a paradox because you can't collect distance. You can't collect the energy of distance. You can only collect the energy of time. So you can drop something 4 times slower, but the fact is dropping it 4 times slower means it never achieves more than 1 unit of velocity. So it won't be able to compress a spring 2 units, because it's not going 2 units of velocity. Still kind of paradoxical. So what breaks the symmetry in the lifting versus dropping is that gravity forces the 1 mass down at 2 units of time, right? But you are saying we lift the 1 mass over 4 units of time. No. I'm saying you can do that. You can lift a mass 4 units slowly, but that'll be 4 times the energy than if you lift it quickly. The point is that you can do 2 units of lift and get 4 units of lift out of the compression you created in the spring. So you can do 2 units of lifting and get 4 units of lift. That's the paradoxical part. But the point is those 4 units of lift are only valuable because you think you're 4 times higher in the gravity, therefore you have 4 times more potential. When your potential at a free fall rate is only 2 units of time. So you're only going to collect 2 units of 9.8. You're only going to collect 18 as your maximum speed, and it's about how fast you're going. You can't, again, if you can move the springs to being in parallel, I could see some way you might be able to take advantage of this, but I'm still, the very fact that you have to move something means you're going to lose all the energy you're gaining. I'm going to work on take care, stay cool, blah, blah, blah. Yes, fine, thank you. So what breaks the symmetry? No, I already did that. Okay. Yeah, so the argument is gravity doesn't have symmetry, right? The argument is that it is doing this 1, 3, 5, 7 thing. It's it's a symmetry, but it's not a symmetrical symmetry. Symmetrical symmetry? I don't know. Probably can't say that. It's not a symmetrical symmetry. It's not a wet thing. Yeah, I think it has to be wet if it's a wet thing. But anyway, yeah. Simple fact is that 9 pounds to 9 pounds isn't necessarily 1 18-pound. You can't make 18 pounds of pressure simply, okay, in terms of exposure by dropping something over separate units of time. So if you were to do, try to make a perpetual motion machine, where you're using the weight advantage thing to launch things and then take advantage of the 4 steps down being more than the 2 steps up, you'd have to use lots of balls flying, so you can collect the energy in the same unit of time, because that's the only way 2 9 pounds can equal 18 pounds is they have to happen at the same time. You can't go down a staircase and create 18 pounds of pressure. Using your idea, the amount of momentum gained being time dependent, then the first half of the spring compression should give more momentum. Why would it give more momentum? Why? Why? I mean, you have to explain that. Why the fuck would it give more momentum? Why? I'm sorry, that's just too stupid. Then the second half of the spring compression. Why? That's not my idea. Using your idea, the amount of momentum gained being time dependent, then the first half of the spring's compression should have more momentum. Why? The spring compresses faster or slower? What's your theory? Because I'm not getting it. And springs aren't gravity. So again, the way springs absorb energy is completely flexible. As pointed out, springs can absorb energy very quickly, or they can absorb energy over a year. I can compress a spring very slowly over a year, or I can compress it in an instant. We're talking about what gravity does as a spring. The gravity spring is completely time dependent. The compression of a physical spring isn't time dependent, because the mass travels the second half faster. Says you. Its acceleration rate is constant in terms of gradually to the point where it launches the object at the higher velocity. So that would be an interesting question, frankly, is if you could prove when does all the energy, the final velocity, when is it reached? Because the fact that the spring's velocity matches the object's velocity doesn't mean much. It'll look like the spring's actually still pushing on the object, but it might already have finished giving it all the energy when it was halfway uncompressed. And it's just moving the same speed as the object, obviously. You can only give something energy while it's in contact with it. Once the object has the energy the spring had to give, then the spring will just expand to its expansion height at its whatever energy it has left. And it can't have more energy. It can't have more velocity, or it would be giving more velocity to the object. But that analysis isn't really any part of this conversation. How springs adjust their velocity to the mass they're pushing isn't really the conversation. I think it's an interesting conversation, but it's not really what's being analyzed. I mean, clearly those experiments would take some sort of slow motion camera film kind of thing. I mean, that's a complex thing to see how fast the spring accelerates the object, and whether it's accelerated before it leaves or exactly when it leaves the spring. Also, the first half of the spring exerts a larger force. Well, no, it doesn't. So you can say it does, it doesn't. So there's absolutely no reason to believe it does. Look, James, I'll just block you if you're just going to make declarations that have reference to no evidence, no experiment, no anything. You saying so? What the fuck? The first half of the spring exerts a larger force. Where'd you get that from? 9 pounds of compression moves it, and then you can't move it any further with another 9 pounds. You need 10, 11, 12, 13, 14. You need more energy to compress the second part of the spring, in the sense that you need something that has the higher velocity. You can't do it. You can't hit it with a 10-mile-an-hour car, compress it to this point, have that back pressure now of 10 miles an hour, and then say, I'll just plow another 10-mile-an-hour car into it and make it go to 20 compression. You can't do it that way. You can't drop the masses independently and say, look, 10-pound mass, 10 pounds of compression. I remove that 10 pounds and then drop another 10, or just leave the 10 pounds there and I drop another 10 pounds. It won't go to 20. They don't add. They have to be added in parallel in the same time. As the spring uncompresses, the force reduces. It says you. At what point does it reduce? It's moving at the same speed. It has the same velocity. So you're saying it doesn't have any force. Well, where have you proven that? What experiment proves that? I mean, clearly, if you stop it from exerting force, that is, you put a barrier in to stop the spring from moving entirely, well, you lose all of its velocity. So now you have to start from zero again. So all of the momentum it had, you've taken now from it, okay, and said you're not going to allow it to release any more of its momentum. So the stopping object's going to absorb all that energy. All the energy of the pressure of the spring will be absorbed by the stop you stick in the way. So again, what experiment? Well, you're not basing any of this crap you're spewing on anything, okay? This isn't part of the real conversation anywhere on this subject. And on top of that, you're referencing nothing. I mean, you're not even referencing a Wikipedia page, nothing. You're just making your declarations. I'll say it again, if that's all you're going to do, then you're not going to be here very long. I mean, let's see, since you're here, do you believe in conservation of momentum? Do you think that is a law? That in a closed, quote-unquote, system, you must account for the momentum. You must find atoms that have it. You can't just make it disappear. See if you'll answer the question. Doesn't seem that taxing. Yes? No? It's not very hard to type. Not hearing anything. Yeah, not seeing any typing. Do you believe springs have to conserve momentum? Hello? Let's see. So Tim comes in with something different. Which exerts more force in this scenario? A 2 mass lifted 1 unit of distance over 4 seconds. I'm not going to do word problems, frankly. I mean, come on. 2 mass lifted 1 unit of distance over 4 seconds, or a 1 mass lifted 4 units of distance over 4 seconds. There are the same amount of seconds, so obviously the 1 mass is a lot easier to lift than a 2 mass. That's gravity. Gravity moves things at the same speed. The 2 mass and the 1 mass move at the same speed. When they hit the ground, what the fuck do you think happens? The 2 mass goes boom! The 1 mass goes boom. You don't know that part? Shit. Obviously, they're going to go exactly the same distance over time. So, 4 units of distance over 4 seconds. 1 unit of distance over 1 second. Yeah, you're still fighting the same force over the same time. It doesn't matter how far you're lifting it. It matters that you're in the gravity. So it's a free fall argument. What's the total energy you have to oppose? The total energy you have to oppose would be the free fall energy. So yes, the time is all that matters times the weight. So 2 mass will require twice as much to lift that 1 distance if you're going to lift it that slowly. You could have just said yes, James, but whatever. Okay, so if you believe in conservation of momentum, I'm just saying, can't you see the trap you're in? That any time I successfully move momentum from a heavy object into a light object, I'm going to break conservation of momentum to create kinetic energy. You can't see that? I can't conserve both. Alright. And compressed clay has no momentum. And compressed clay has no momentum. Yes, when it's done moving, it's done moving. The movement causes heat. Okay, so we know the temperature of the clay rises when you move the particles of clay. And the clay stops moving. The little bits that are visual, they stop moving. The clay itself is still moving atomically. So everybody knows that's what happens. Crush the clay, it gets hotter. Rubber bands get hotter and colder, through expansion and contraction. These are real effects. That's where the energy goes to die. It dies as heat in the sense that it will live on because it will radiate the heat into other things and all that kind of crap. But I'm just saying it dies from our visual perception when it's converted to heat. Let's see. The compressed clay has no momentum. Therefore, you use no momentum. So I don't know what you're talking about. You're fucking out of your mind. Because it is transferred. What the fuck are you talking about? And the compressed clay has no momentum. What does that mean, you fucking nut? Compressed how? In what circumstance was it compressed? So you're saying atoms don't have momentum and electrons and protons don't have momentum. Yeah, they do. You're an idiot. Let's see. Do you agree you can collide with an object? That object moves a miles and then collide with another object. I don't even know what that is. So you're just a time waster, right? Oh, I mean, what are you really asking? You're asking me what? Do you agree that you can collide with an object? Okay, so there, I collide with an object. That object moves a miles. Which one? If I do this a certain way, this reflects and this goes with part the energy. The whole point is unequal masses don't convert energy. So if you're saying, are they the same mass, and I collide this into this, and then now this one's moving, and now it collides with something. Yeah, duh. I mean, this is, you can't see how your argument technique is just completely troll. Can you provide some evidence of something you're arguing for? Can you show a single fucking experiment? Show me it taking 4 times the fuel to go twice as fast somewhere? Can you show something besides whatever the fuck this crap is as a non-argument? Do you agree that you can collide with an object, that object moves a miles, and then collides with another object? What the fuck is that? I've already pointed out that I agree with Descartes that the energy is constantly moving from object to object in the universe. It's quite obvious that's what takes place. Objects hit each other, touch each other. They exchange their energies, depending on how long their contact is. And that's what keeps taking place in the universe, is everything is neutralizing its aberrantness by having contact. The more contact it has, the more it becomes the same. Everything becomes the same. The less contact, the less the same. Fuck you. That object just displaced, and that costs no momentum. There's no such thing as no momentum. There's no movement without momentum. Nothing moves without using momentum. You fucking lying sack of shit. Dude, show me any of this. Whatever this is. This moronic crap. I'm just going to block you. You're just giving me no choice. You have typed nothing but distracting nonsense here. There's nothing to say to it. It's nonsense. Will you please do something? Will you say something relevant to this subject somehow? You have no demonstration of a no momentum event. No demonstration. You have no experiment where no momentum made momentum. The momentum has to be stored in a battery. It has to be stored somewhere. God, you're such an idiot. Stupid, scummy shit people. So let's see if somebody else has something to say. If not, I'll just get out of here. Alrighty then. Well, we're at 155. I probably could last a little longer. Somebody could actually make a rational counter-argument. So I just ask you, James, do you think gravity happens per unit of distance and not per unit of time? I mean, do you think it's 9.8 meters a second, or do you think it's 9.8 meters per a unit of distance? Have to wait forever for the answer, I guess. Another yes or no question. Well, I think it was yes or no. Yes, you believe gravity is time dependent. It's all about how long you free fall in the gravity will decide how much force you collect from the gravity. Do you believe that? I think it's more useful to use time as this method is more accurate, but using distance can give the same result. Well, that's the whole point. It only gives the same result in the perfect Newton's cradle circumstances. It doesn't get the same result when you start changing the masses. Momentum works. I'm just saying, okay, well, let's do the spaceship one, James. So, James, I shoot a bullet out one side of the spaceship at 2,000 joules worth of velocity, and I shoot the recoiling gun out the other side a moment later with 2 joules of energy by your definition. What does the spaceship do? Does it turn or does it stay straight? May I suggest reading up on... Fuck you, Tim. I guess I'll block you too. Yeah, fuck you. I mean, really, fuck you. I suggest you take your head and pull it out of your fucking stinking ass. That's what I suggest to you. Deflagration in the process of the bullet accelerating down the barrel of the gun. Doesn't have anything to do with it. Obviously, you can take energy off of the bullet by having, the bullet spin, do lots of things. So there's lots of ways you can take a little bit of the energy off. But we're talking about a gross number here. You're saying if I had 2 guns and I fire the gun with 1 explosion, the 2 guns leave with a total of 4 joules of energy. And if I do the opposite circumstance of putting 2 bullets and 1 explosion inside 1 long barrel, I get 4,000 joules of energy out of the same explosion. That's your fucking-tarded theory, shithead. Explain how that wouldn't actually happen. That wouldn't be the practical end result of those 2 experiments. 4 joules, 4,000 joules. From the same explosion. Bullet explosions happen really fast. So, there certainly could be some reflected energy, that gets to the bullet and pushes it a little. But because it's happening so fast, it's not likely to be much. And it really doesn't get to the core of the argument. The core of the argument is, okay, Tim, if you theoretically, okay, if we just play the thought experiment thing for a second and just say I can make a perfect lever, all right, and I can make it in space at this any length I want to make it, and it will not bend because it's just a rule. You do understand that I could do the gun bullet thing. I could have the gun recoil pressure on one side of the lever, and I could create the bullet velocity on the other side of the lever. Do you concede that momentum allows you to do that? And that by kinetic energy theory, it would be free energy. Yes, I have to break the rules of physics a little tiny bit by making an infinitely light structure. But you can almost imagine that possible with all this carbon graphene kind of crap, that you could make a very long lever out of a very little mass. You know, you believe in dark matter, it shouldn't be that hard to it stays straight. There you go, okay. So the momentum works in space. There's no evidence of the kinetic energy working in space, so you're conceding the argument, fine. But the bullet will displace more matter. How so? How does it displace it without momentum? So just explain to me how it does that. How exactly it does it. How it hits other objects and gives them more than just exchanges of momentum. Like the bowling ball. You're telling me the 8-pound bowling ball can give away more momentum than it actually has. More energy than it actually has in terms of momentum. Because all I can understand is it can only give its speed to the object it hits. That's the way it works. And it's going to run out of energy quickly because it gives away a lot more speed to each pin it hits. One mass would travel a mile. Oh, this ought to be funny. You started going with travel distance. One mass would travel a mile, while the one mass would travel half a mile. The one mass would travel a mile, while the one mass would travel half a mile in the same time. Well, that made no sense at all. Thus displace more matter. I'm sorry, this is baby talk. It's worse than baby talk, it's drivel. So just fuck off. Oh, half mass. Well, which one's supposed to be the half mass? The one mass would travel a mile, while the half mass would travel half a mile in the same time. Again, we've already been over all these arguments. In space, it doesn't work that way. I'm sorry. You're going twice the speed, you go twice as far. The half mass goes twice as far. So what? It has half the mass. It has half the momentum. I mean, it has half the mass component to its momentum. The momentum is exactly equal. The gun and bullet don't have equal kinetic energies. We're talking about kinetic energy. I mean, you just keep changing the subject. Let's see, Tim says, there is a pressure buildup in all surface areas as long as gunpowder canister of the bullet. Yeah, the explosion goes in all directions. And if there's matter in the way, it moves the matter much slower than the particulates of the explosion, because it has to exchange its momentum. What's leaving the bullet? Little tiny bits of energy. Some of it in the form of photons. Some of it in all kinds of ions. Very fast-moving little atomic bits. And they transfer their energy to the little heavier bits. The heavier bits move much slower. They can't get very far. They certainly can't go far enough to reflect and then hit the bullet again, because the bullet already fucking left. Isn't most of the pressure is going to build up and down and sideways perpendicular to person? It's just about hitting surfaces. So when it hits the surface, it will give its momentum to the surface. That's the idea. It's going to be mostly inelastic. I mean, elastic. I have to think. Inelastic collisions. They're going to stick. That's why the gun gets dirty. This stuff sticks. Look. I'm just saying, you could take even if you wanted to say that there is some back pressure rule that you can rely on. It's a tiny percentage of the 4 to 4,000 differential. You're not going to make up the 4 to 4,000 differential by saying, stuff bounces off the gun and hits the bullet. Besides the fact that I don't think you have any theory to defend that. Just because the bullet is moving very fast. Very fastly. Yeah. In my opinion, the calculations stand for themselves. I'm just saying, do you theoretically understand that I could put a gun inside of another gun barrel and fire the same charge that's in a bullet, and the two guns would basically just be two recoils, and that would have 4 joules of energy calculated out? And that I could put 2 bullets inside of a zip gun, pointed in opposite directions, with only 1 single charge, and that the 2 bullets, will equal 4,000 joules in total, 2,000 for each bullet. Do you understand how that doesn't make any goddamn fucking sense at all? And momentum explains it perfectly. 1,000 times fewer atoms moving 1,000 times faster. There's nothing very confusing about that. All right. Yeah, we already did the pressure argument. You'd have to concede that the instantaneous pressure is the highest pressure, right? The initial pressure is the highest pressure. And it goes down from there, like the nuclear bomb or something. Let's see if I come up with an analogy. It's not a good analogy, right? Because it's moving the atmosphere, and that's a big difference. All right, because that's like an airbag. Yeah, it's made of air, the atmosphere, so it's like an airbag. But I mean, the initial energy is the maximum energy, and it goes down from there. It decreases with time. So I think it's going to be hard to make a ballistic argument that somehow the lower pressure that happens after you've already hit the bullet with the higher pressure catches up to the bullet and pushes it more. No BC of deflagration. I don't know what BC means. No, because of deflagration. I don't know what deflagration. Anyway, it's controlled burn. Whatever. Okay, just keep making shit up. Fine. It's a high explosive, a controlled burn. Oh yes, it's just a little brush fire. I mean, fuck. Too pathetic. So there's defragmentation when I put the two guns. I put a gun inside of a gun. There's what? What happens to the energy? I'm just saying. What happens to the explosion? Where does it go? It's only making 4 joules of movement of the gun. So where did all the energy go? The action of heating a substance until it burns away rapidly. So again, what does that have to do with anything? Those are just losses. Every explosion will have losses in the sense that you're going to heat the gun in places that are totally useless and aren't going to make the bullet go further, ain't going to make the gun go further. The gun barrel will expand. Lots of things are going to take place. You have to make the argument that they account for 3,994 joules of energy. And you're not going to be able to show that. I mean, this is such a cop-out. I'm just going to sit there and say the waste got insane. You know, the amount of heat waste. You're just saying it. You're not going to show that with any experiment. That's like the argument with friction. Oh, it rolled 4 times further. Well, yeah, it's 4 times as much energy went into the ground. Did you prove 4 times that more energy went into the ground? Or are you just saying it? Because I'm saying if I go 500 miles an hour across the surface, I'll bet you a good zillion dollars that I'm not going to make the ground all that hot. The ground ain't going to barely know I was there. Just how the desperate cling to this crap. This silly Leibnizian theory. So again, I'll just point out to you, Tim, you're defending the logic of a man who believed in solitons, and he thought Descartes and Newton were 2 atheists in their physics. That's what you're defending. A completely unevidenced pile of mush invented by somebody who was hostile to physics being mechanical. Yeah, well, the recoil just has to do with how much you're allowing the gun to stop. So if you want to get rid of the recoil, you just leave the gun open. Like the old muskets, you know, they used to they would shoot a lot of crap back out at you like a bazooka. And so, you know, they were really dirty for the shooter because he was exposed to a lot of gunpowder and other shit. And so when they made the firing compartment a sealed compartment, all right, that increased your recoil. And then when they started loading the gun, you know, shooting the cartridge out and putting a new bullet in and all that crap, that's more energy it's got to absorb, so it increases the recoil. So the more work your gun is doing, the more recoil you're going to feel. Because the less of the exhaust you're letting out of the gun. If you don't let the exhaust out of the gun, if you don't let the explosion out of the gun, the half heading for you, then you're going to have to absorb the impact of it. So the simpler the gun, zip gun, the less recoil. I mean, besides what you're using to fire the zip gun, of course, which is the tricky part. The gun will have no recoil. Your trigger could have a lot of recoil. The only thing I'm saying is that I think the guy bullet example is complicated, and that makes it a bad example. Well, I think it's so fucking simple and easy to understand that fuck you. You're incorrigibly stupid, and so you don't want to do logic and you want to find excuses to cling to bullshit. I can't do much for you, but to me it's a fucking brilliant example. You've got 1,000 atoms moving 1,000 miles an hour versus, just as an example, versus one atom moving 1,000 miles. I mean, 1,000 atoms moving 1 mile an hour versus one atom moving 1,000 miles an hour. You say the one atom has 1,000 times more energy. It's retarded. My question is, how would you describe the relationship between momentum and gravity in the form of a formula? What the fuck formula is there? There's no formula you need. MGT. Done. I mean, believing in momentum, Newton invented 9.8 meters per second, and Newton believed in momentum. So you do understand 9.8 meters per second, that formula is already invented, shithead. And we're not changing the gravitational constant, retard. We're just recognizing that Newton, Descartes, and Galileo believed gravity was a time-dependent force, where you retards think it's a distant dependent. I mean, the gun the bullet example to me is just so decisive, because it's, again, you can understand that, like Archimedes, or whoever the hell, it wasn't Archimedes, but he said, give me a lever long enough and a fulcrum to set it upon, and I shall move the earth. I mean, this is 1,000-year-old logic, and you're just looking for ways to reject it. Can you represent that in the form of a formula? What formula do you want? That is a formula, you shit. For brain, energy equals mgt. What more formula do you want? That's how you get energy from gravity. Your mass times the gravitational constant of where you're located times how long you're in that constant. Jesus fucking Christ. That's how much force you'll either gain, or that's how much force you'll resist. That's how much energy. Energy and force are the same thing. You want another formula? E equals F. There. And it also equals weight. And it also equals heat. And it also equals, what's the other one? There's another, velocity. No, it doesn't equal velocity. What's the other one? But yeah, that's it. It's really simple. E equals mv. Time is just, well, I'm going to just block this guy. Time is just a construct of men to measure distance. You're an idiot. You cannot hold the Bennett, shape it, and especially not travel along it. It's not physical. Well, of course it's not physical. Distance doesn't make time, you fucknut. I don't have to go anywhere for time to happen. You jackass, you retard, you fucking douchebag, shit for brain fucknut with a fucking idiotic, unpronounceable fucking goddamn name. Oh, I just hate you. You people, you whatever you are's. Ugh, these people with their own little personal pile of mush theories. Yuck, puke. Can you think of atoms gravitating each other? Well, obviously, I'm arguing that charge is the origin of the forces between electrons and protons. So gravity is an expression of the consumption of that force. But whatever, the longer it takes to travel, the less the matter is displaced, travels, therefore more kinetic energy. What the fuck? The longer it takes to travel, the less matter is displaced. How do I make any sense out of that mush? Whether you put the gravity on an atom or whether you put the force pushing, doesn't matter. It's a force pushing. Electrons and protons push on each other, okay? I mean, electrons on electrons, protons on protons. And they are pushed into each other by a force. Idiot. And it just has to do with what the force is at those distances versus those masses. The gravitational constant will not be 9.8 meters per second for atoms. Oh, fuck. I said it's a construct of man. Fuck you. Time is an actual function of the universe. The universe functions with time in it because nothing happens instantaneously. Things move and it takes them time to do it. Okay? It's a thing. It's a real fucking thing. It's an event thing, fuckhead. It's not just a construct. It's an accurate description of a fucking event that takes place in the universe. Slowness is an event in the universe, you dumb fuck. If light moved instantaneously, then there would be no time and there would be no universe, you dumb ass, because everything would happen instantaneously. It'd be over already. Fuck you. I don't need to read it again. I saw it the first time. It's tripe. You don't know the difference between functions and things? There's things in the universe and they have functions. Okay, that is, they interact with other stuff in the universe, other things. And the byproduct of that are things we call a function. And the argument is the force bits have an innate function, which is going the speed of light, and the matter bits have an innate function, which is they're pushed by forces. Let's see. How long does it take to get somewhere? So a man creates time. Oh, you're just saying the same thing. Goodbye. You're done here. Fuck that. The exact same cripey fucking tripe. Jesus Christ. Can you think of atoms? Okay, we already did that. There's just force and matter. That's all there is in the universe. The force moves the speed of light. The matter does what the force tells it to. Oh, fuck. The balance of force tells it to. Alright, so now we will declare this a video. Yes, I did 2 hours, more than 2 hours, so. Didn't cheat you, really. But God, I hate your guts. You people are just so annoying. I just keep clinging to this mush. Sorry, impossible question here. What keeps track of all the forces bits? Reality keeps track of them. Because they're in real places, in space, doing real things, and it's all cause and effect. Another Descartesian concept, cause and effect. And tells them to go the same speed. They're not told to go the same speed. It's just their function. That's what they do. So I can't help that that's the way the universe appears to be, but it appears that all the forces are stuck moving one stupid speed, and that's the way it works. So yes, I don't tell them how to be force bits. Okay, that's their nature. So I don't know what you want for an explanation. So you want me to exactly show you what a force, quanta of force in the universe is? Yeah, well, I can't do that. But I think it's really simple. Unlike Leibniz, I don't think God done it. Whatever. Fuck. Fuck, 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 fuck. So, till the next time and such, and so forth and whatnot. God, I hate this planet.